Hello. Today we're going to be starting our new chapter, which is on logs and exponents. Specifically today we're talking about exponential functions, and then tomorrow we'll get into some logistic functions as well. So let's get started here with the definition of what an exponential function is. An exponential function in x is a function that can be written in this form: f of x equals a times b to the x power. In that form, a must be non-zero, because if a were 0, then you would just have f of x equals 0, which is not exponential. B must be positive, and we'll talk a little bit later about why that is, and b cannot equal 1. The constant a, that's called the initial value of f. That's the value when x is 0, and b is the base. Now, let's talk about some of these limitations that I've highlighted here in a little more detail. Let me get over to my other pen here. So, I already talked about why a can't be 0. Because if a were 0, then you would just have, that's not right. You would just have f of x is equal to 0, not exponential. So that's why that is the case. Second, b has to be positive. This really would become a problem if b were negative if you were graphing. So, for example, let's say you had f of x equals, just make an easy one, 1 times negative 2 to the x. The problem with that is, first of all, this exponent here. There are so many values for x that would not be in the domain of this function. Because, for example, if I tried to raise negative 2 to the 1/2 power, well, raising to the 1/2 is the same thing as taking the square root. So I would be taking the square root of negative 2, which would be an imaginary. And so we don't want any imaginaries to be in our outputs. So in our domain, we would have to exclude anything here for x that would give me an imaginary output. Well, there are infinitely many numbers that would give you an imaginary output. Actually, if x were anything that had an even denominator, then you've got a problem because you can't take an even root of a negative number. So that's one of the issues with a negative root there and why we don't allow that when we're talking about exponential functions. This third expression here, b can't be 1, that's because if b were equal to 1, then I would have f of x equals a times 1 to the x. Well, 1 to the x is just always 1. So this would just equal a times 1, which is just a. That's not exponential either. That's just a constant function. It would just be graphed as a horizontal line. So that does not give you an exponential. So these 3 issues right here are really important as far as what the base can be, so you need to watch out for those. This constant a is called the initial value. And the reason why that's the initial value is because if you think about it, okay, so let's just say I have like f of x equals 2 times 3 to the x. The initial value is what you would get initially for the function. So when x is its initial value, x is 0. If you had 2 times 3 to the 0, well, 3 to the 0 is just 1, so that's just 2. Notice 2 is the value that I got when I put 0 in for x up here. So that's why that 2 is the initial value. And it'll always work out that way. Whatever this a value is, that will be your initial value. And so that's what we use there. And then b is called the base. Okay, so that gives us our basics as far as what an exponential function is. Let's go on to the next page here. Let's see if I can make this happen. There we go. And identify which ones of these are actually exponential functions. So the first one we have is f of x equals 2 to the x. This one is an exponential function. What you're looking for, remember, is the form f of x equals a times b to the x, and there were all kinds of restrictions on b. So this is in that form. A is the initial value, b is the base. A in this one is 1, because imagine there is like a 1 times 2 to the x sitting out there in the front, and the base is 2. This second one, g of x, now that is not in this format. There is no x as an exponent like there was in the first one. So this one is not an exponential function. It is, it has x raised to a power, not a base raised to x there. Okay, the third one, h of x, that one is 5 times 2 to the negative x. That one, even though it seems kind of strange because it has 2 to the negative x, remember what that means when you are raising something to a negative power. So really, I could rewrite this as 5 times 1 over 2 to the x. That's what it means when you raise to the negative power, take 1 over that. Or in other words, think of it as 5 times 1/2 to the x power. Those are all equivalent. Now that you see it in that form, hopefully you can see, oh yeah, it's in exponential form, where the initial value is 5 and the base is 1/2. Now this last one here doesn't even have an x, so it is definitely not exponential. Either. Okay, so let's move on to number 2 here. And this says we want to compute the exact value of this without using a calculator. So we're just going to take this 1/3 and plug it in here in place of x. So f of 1/3 would be equal to -5 times 8 to the 1/3 power. Reminder, if you're raising to a fractional power like that, that means root. In this case, it's the cube root. The cube root of 8 is just 2. And so you would get a result of -10 there. Okay, moving on. On example 3, it gives us a table with values for 2 different exponential functions, and we're supposed to determine the formulas for the functions there. Okay, so if you look first at f of x, that is in this column right here, so we're just looking at these x values over here, and then the f of x values next to it. So the first thing we need to figure out is what is a, the initial value. And that's really easy to find because all you do is look at the value when x is 0. Right here. We see that when x is 0, the f of x value is 3. So that makes 3 the initial value, or our a. To find the base, what you need to do is figure out what are we multiplying by each time? What's the pattern? And if you notice here down at the bottom, like to get from 3 to 6, you multiply by 2. To get from 6 to 12, you multiply by 2. And even up here on these, same thing. 3/4 times 2 is 3/2. 3/2 times 2 is 3. So therefore, this 2 is the b value. B is what you are raising to a power each time. So from that, I can tell what my function is going to be here. For f of x, it's a, which we said was 3, times b, which is 2 to the x power. Now, over here on the other column, these are the g of x values. We're going to do the same thing. Again, you just look across when x is 0, what is the y value that we have? And that's 5. So therefore, this is my a, my initial value. To find b, we look and see what are we multiplying by each time to get from one term to the next. And I see I'm multiplying by 1/2. Multiply by 1/2, same here, same here. I'm always multiplying by 1/2 to get to the next term. So my b value is 1/2. So g of x here is a, which is 5, times b, which is 1/2 to the x power. Okay. So we're going to end this video here. You'll need to watch section 1, video number 2 for the rest of today's lesson. And I'll see you in a minute.